Okay, today we're going to look at the rational root theorem. So when we have, say, a cubic that we have to, say, factorize, and we haven't been given the first factor, say something like that, up here with x cubed plus 2x minus 5, we have to try and find the first factor so that we can then do the division. So the rational root theorem is what we can use to help. And what we're going to do is use the number or the factors of the leading term. So say for this one, it would be 1 up here. And also we're going to use the factors of the constant, say, which would be like, say, -5 over there. So the rule, so you're actually using the coefficient of those two terms. And the way you can find a factor is, so when they say the solution for x, so say if you end up having, for example, x plus 1 is a factor, we know the solution would be x equals 1. So they're saying that, -1. So they're saying, yeah, for the solution, you can use this formula here where you've got p over x. So p is a factor of the constant term. So say up in our example would be -5. And q is a factor of our coefficient of our leading term. So up in our example would be, up here, would be 1. Okay, and here, down here. So the formula to try and find a solution, which can help us find a factor, is x will equal a factor of the number in front of the constant, the constant number. So say my example here now would be -3, and a factor of the constant in the leading term. So here we've got, over here it would be 2, factors of 2. So factors of 3, etc. So factors of -3 could be negative and plus 1 and negative and plus 3. And factors of 2 could be plus or minus 1 and plus or minus 2. So there's a few combinations. So we'll do an example on the next page. So use the rational root theorem to help factorize the following polynomials. So I've had a look at the following polynomial and I've found my leading term and its coefficient is 2. So down, and I found the constant and the coefficient is -15 is the constant. So here these are all the factors of -15 I'm listing, and here underneath all the factors of 2 have been listed. So technically we could have a possible solution could be all these. So say for example 1, we would have taken the plus 1 over plus 1 and we would have got 1. Say with the factor of 3 on 2, we took the factor of 3 from the 15 and a positive 2 from the 2 coefficient. So we've got a lot of these, but now you can use these to sub in. So you go p of 1 and you find out what that equals. For example, so it'd be 2 minus 7 plus 16 minus 15. So that does not equal 0, so it's not a factor. So you're probably best to define if you don't have your calculator, we just got to keep trying. So 1 was not going to do it, because if you have a look at this, we would have got -6 plus 2, so we got -4. So it actually equals -4. So it's not far off, like it's not a huge number away from 0. So I'm going to try the 3 of 2, which is a little bit more than 1. So if I put p of 3 of 2 into this formula, okay, and we obviously get it equaling 0. So therefore, we know that if p of 3 of 2 equals 0, we know a factor could be 2x minus 3. So remember that this is the b value. We make it negative there. b, and that's the a value. So remember the factor theorem rule. Okay, so obviously doing the rational root theorem, it still takes a long time because you've got, like in this example, there's a lot of possible, with that 15, there's a lot of possible factors. So we might be doing a lot more of this using our calculators to get the first one, and then they might ask you to say, show how, you know, using division, how you get the other answers. So I'm going to show you on the next page with the calculator. So a couple of possible ways we could do it is, you know, to save time, you could define the function. So you remember menu, actions, and define, and you pop in your polynomial, which I've done, and press enter, and you get done. So then I could try a few of the factors. So this is the same example as before. So we've got factors of 2, which is that, and then we've got factors of the 15, etc. So here I just decided to do p of 1 just to show you. So I put p of 1 and it tells me, and then obviously we knew that 3 over 2 gives us a factor, but when we see it, we got 0. So you could work it out. Otherwise, if, as I said before, when you might just want to get the first one, so we'll just factorize the expression straight off. So we get factor by going menu, algebra, and factor. And so when we get that, we get this answer. So I can see I've got one factor, 2x minus 3. So therefore, I might use that one now. And if they'd said show how it is a factor, so I might start my long division. So I've got 2x minus 3, if they ask me to show it. And then we're going to do long division of the 2x cubed minus 7x squared plus 16x minus 15, and you would process through that, and you should end up with the answer, that second part. Now obviously this second part, it can't be factorized because otherwise they would have put, the calculator would have put the 2 factors there. So this one can't be factorized, and let's have a check using our discriminant. So remember, the discriminant is b squared minus 4ac, where this is the b value, 1 is a, and c is 5. Now, so if you do the discriminant of this formula, so it's negative b squared minus 4 times 1 times 5. So you get 4 minus 20, which equals negative 16. So if you remember back, therefore, when the discriminant is, we could say less than 0, or essentially a negative number, there are no solutions to the quadratic. So that is why when they couldn't factorize this anymore, because there's no other solutions. So if later on when we do go to sketch this graph will have a x-intercept of 3 on 2, and that'll be the only one. So it'll come up, whatever it does, and it might do something like that, and you know that this is 3 on 2. Okay?